morning, everybody. So first of all, this is the second video in the series for chapter 5.1 or section 5.1. And so I'm actually doing problem 53 out of the textbook. And the instructions basically say, find a polynomial function with the given real zeros and whose graph contains the given point. Okay, so our zeros are -3, 1, and 4. Our degree is 3, and our y-intercept is 36, which basically translates to our ordered pair is 0, 36. And any ordered pair we're given, we can follow the same process that we'll have through here. It's not special that it's the y-intercept. Okay, so what we do is each zero or each root comes into the factor as the opposite. So if it's -3, it's x plus 3. If it's +1, it's x minus 1. If it's +4, it's x minus 4. And what we need is some type of multiplier, and the multiplier is an adjustment to make sure that 0, 36 will be on the graph. So what we do is we'll multiply these out. So what I did was I multiplied these two together first. So x times x is x squared, -x, 3x, -3. And then I combined like terms. But notice I kept them in a set of parentheses because it's this times the result of this times this. And so I have, when I combine like terms, x squared plus 2x minus 3. Now I'm going to multiply these two together, and you're just going x squared times x is x cubed, x squared times -4 is -4x squared. Now you do 2x times x and you get 2x squared. 2x times -4 gives you -8x, and then -3 times x is -3x, and -3 times -4 is a +12. And we combine like terms and we get this expression. And notice that we still have the a out in front. Now, what do you do with that? Well, we know that the ordered pair, and I'm pointing up here, 0, 36 is on the graph. So your x value is 0. So wherever the x is, you put a 0. We still have the a out in front. And then it's going to be equal to 36. Well, when you plug 0 into x cubed, you get 0. You take 0 squared, and you get 2 times 0, which is 0. 11 times 0 is 0. So you're really left with just 12a equals 36. Divide both sides by 12, and you find out that your a is 3. And so your function, which you had up here before, gets the 3 put in place, and then we just end up distributing it. And we get 3x squared minus 6x squared. 3x cubed, that's a typo, minus 6x squared minus 36x plus 36, and that's your polynomial. Okay. Turn the page here, if I can get there. So I did another problem, and we're just, repeating the process. So this one has -1 with multiplicity 2, and this one has +1 with multiplicity 2. And degree is 4, so our zeros are -1 and 1, but they each have multiplicity 2. Our degree is 4, and we end up with a point of -245 on there. So I did the +1 first, and I wrote it as x minus 1 squared, and I did the -1 second, and I wrote it as x plus 1 squared. Remember, it comes in as the opposite. Now I did something a little weird here, and I recognize that. So instead of writing it x minus 1, x minus 1, x plus 1, x plus 1, I remembered that if I put them as a -1 plus 1 and a -1 plus 1, and I can do that because multiplication is commutative, I can get, when I multiply these, x squared minus 1. So x times x is x squared. You'll get a positive x and a negative x, and they drop out, and then you're left with x squared minus 1. And that happens twice, so I have 2 of those. Now I'll FOIL that out, and I get x to the 4th minus x squared plus 1. And I combine like terms, and I have a -2x squared in the middle. Now, remember we have the ordered pair. -2, 45. So wherever there's an x, we put a -2, and we have it equal to 45. And so I have a -2 to the 4th power minus 2 times -2 to the 2nd power plus 1. And this becomes 16, and this becomes 8. And it becomes a -8 plus 1. Now, 16 minus 8 is 8. 8 plus 1 is 9. So I have 9a is equal to 45, and we divide both sides by 9, and we get 5 is equal to a. Okay. Well, what that means is that thing gets the 5, and so we really have 5 times the quantity x to the 4th minus 2x squared plus 1, and we distribute the 5, and we have, 5, the quantity x to the 4th minus 2x squared plus 1, and we really have 5x to the 4th minus 10x squared plus 5. Okay, so you need to read a portion in section 5.1 about end behavior. And basically, what that means is, and I'm just going to quick sketch this. So y equals x to the 4th, if you just take that as the base function, not around the origin, but at the ends, at the extremes, as you head off to infinity, x to the 4th is going to act a lot like this, even though it has all this other stuff. Well, what it's basically saying is, all right, so here's your x to the 4th equation here. It's going to do something like this. It'll go beer, 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 beer. Okay, so it can have up to 3 turns. Well, x to the 4th is just going to do this. And it's not talking about this region, but it's talking about when you start heading off into the infinities. They just start to behave a lot like each other. And so it's called end behavior. All right, let me hop over here. So on 71 and 73, these two, we're supposed to look at it and sort of describe what's going on. So this is not a polynomial. The reason it's not a polynomial, it's not smooth, it's not continuous. This one over here, this is a polynomial. It has a root here, and it has a root here. Now this is an odd root because it crosses through, and this is an even root, and that's because it just touches and it rebounds. Now, if we were to talk about its actual multiplicity, most likely this is a root of 1 because it looks like a straight line, and this is a root of 2, or multiplicity 2, forgive me, because this looks like a parabola. We'll take a look at 76, and it says, okay, give us a polynomial that's a possibility. All right, well, this has a root of 0, 1, and 2. And this one's got even multiplicity because it just does that little rebound right there. So our roots are 0, 1, and 2. So the 1 comes in as the opposite. The 2 comes in as the opposite. Because it has even multiplicity, we square it. This is actually x minus 0 times x minus 1 squared times x minus 2. But if you subtract 0 from anything, it just is that thing. So it's just x. And so that is a possible polynomial. Okay, hopefully that helps.